So dynamic memory allocation means what? Allocating memory during runtime from the heap location. It's known as dynamic memory allocation, right? So now you see, suppose you are statically allocating an array. Suppose you have declared an array integer a of 10. So what you can do, you have allocated memory space for 10 integers, right? So you see here you have allocated memory during compile time. So when you have compiled your program, then the memory for 10 integers has been allocated. Now during runtime, suppose you think that I want to use 15 number of integers, then you can't do because you have allocated the memory statically. Next, suppose in runtime you think that no, I want to use 5 integers, so you cannot squeeze it. So here in static memory allocation, there are two problems. So in case of static memory allocation, there are two problems. What are those two problems? One is there might be a shortage or wastage of memory locations. Memory allocations. Right? So in order to avoid this problem, we have come up with a solution that is called as dynamic memory allocation. So in dynamic memory allocation, during runtime, means when you are executing your program, you can extend the memory locations or you can squeeze the memory locations based on your requirement. Right? So in C, dynamic memory allocation can be achieved by using three functions. One is malloc, second one is calloc, third one is realloc. So these are the three functions by using which what you can do, you can dynamically allocate the memory. And there is another function that is called as free. By using this function, you can dynamically deallocate the memory occupied by these three functions. Right? So let me first go through malloc. Let me use the malloc and free function first by using a program so that you can clear regarding the dynamic memory allocation. Right? So first let me write the malloc function. So malloc is a predefined function. These all are predefined functions which are defined in the header file alloc.h or stdlib.h. Right? Now you see malloc, the prototype of malloc is void pointer. Its return type is a generic pointer, that is void pointer. Then the function name is malloc. Then here it will occupy the requested amount of size. So here I can write it size in bytes. So how many bytes you want to occupy, you have to specify over here, right? So why it is void pointer? Because by using malloc you can allocate memory for integers. By using malloc you can allocate memory for characters, for floats, for doubles. So like all data types, for all data types you can allocate the memory dynamically by using malloc function. So what is the advantage of void pointer? So malloc will return what? It will return the starting address of the allocated space. So what malloc will do? Malloc allocates the requested amount of memory dynamically and returns the starting address of the allocated space, the starting address of allocated space if the memory is available contiguously. Otherwise, it returns null. Right? So suppose you want to occupy 100 memory locations. So what it will do, Malloc dynamically allocates 100 memory locations and returns the starting address of the available memory, allocated memory, if the memory is available. So if 100 bytes are available contiguously, then it will allocate it and return the starting address. Otherwise, what it will return? It will return a null. Right? So now let me write a program to dynamically allocate memory and find the sum of array elements. So now here you see in array what we will do in static allocation. So integer a of 10. So what it will do, it will allocate, so it will allocate 10 integers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's say its starting address is 1000. The next address will be 1004. Next address will be 1008. Like this it will continue. So what is A? I have already told you array name is a constant pointer which always points to the starting address of the array. It means it stores 1000. Right? So in static allocation you are doing like this. So in dynamic allocation what we will do? In dynamic allocation we will just declare a pointer, integer pointer A. Right? Next a equal to integer pointer. We will convert the void pointer into integer pointer. Then malloc. How many bytes you want to occupy? 10 into size of integer. So 10 into size of integer means 40. So it will occupy 40 bytes contiguously. So what it has done? It has occupied 10 years. Memory for 10 years. 3, 4, 5, 6, 7, 8, 9, 10. So it is allocated it dynamically. So this memory will be allocated from the stack area, whereas as it is allocated dynamically, this memory will be allocated from the heap area. Right? Next, let's say its address is static address is 2000. So 2004, 2008, like this. Next, here what A will store? You see a is a pointer. You see a is a pointer, integer pointer. So a, so you see malloc. What malloc will do? Sir, malloc will allocate the memory requested amount of memory dynamically and returns the starting address of the allocated space. So what is the starting address? 2000. So here it will return 2000. So now it will point to here. So you see this is static memory allocation, whereas this is dynamic memory allocation. Right? So you see both the things are same. Here A is a pointer which is pointing to the static address. Here also A is a pointer which points to the static address. But the difference is here
बहुत लो आ रहा है.
अभी भी सुनाई नहीं दे रहा है.
सब सुनाई दे रहा है लेकिन बहुत लो आ रहा है.
अच्छा. Okay, today I have changed the earphone. Okay, let us continue. You try to listen, right? What else I can do? I can change. I have already changed the earphone. Okay, you see. Now it's fine. अभी सुनाई दे रहा है?
Yes, sir.
Yes, sir.
Dear students. Dear students.
Yes, sir.
अभी सुनाई दे रहा है?
Yes, sir.
सुनाई दे रहा से बहुत लो आ रहा आवाज.
अच्छा, you try to listen to it or what I will do. I have already changed the earphone. There might be some problem with the system. So here you see, here we have allocated the memory dynamically. So malloc does what? Malloc allocates the requested amount of memory dynamically, and if the memory is available, it returns the starting address. So you see, what is the return type of malloc? Malloc's return type is void pointer, which is a generic pointer. But here you see, what is a? A is a integer pointer. That's why I have converted or typecasted this void pointer to integer pointer, right? So now, this is all about dynamic memory allocation. Now let me write a small program to illustrate how you can allocate the memory dynamically and how you will write a program by using that. Okay. So let me write a program to allocate the memory dynamically and write a program to allocate memory dynamically and find the sum of array elements. I will find the sum of array elements, right? So let me divide the screen into two parts. So first I need to include the header files. So hash include stdio.h. Now in order to use dynamic memory allocation, I have to use the functions malloc, calloc, realloc and free. So those functions are defined inside which header file? stdlib.h or alloc.h. So I have to include them. So include stdlib.h. Okay. Okay. So let me do one thing. Let me increase the volume. Okay. Next. Next, I have to start the main function, integer main. Right? Next, I have to declare an array. But here I want to declare the array dynamically. So what I will do? I will declare a pointer. So let me take the array as integer type. So integer a. So a is the array name. But here I am declare a pointer. I will allocate memory dynamically. Integer a, then size of the array that we will enter during runtime n, then I, then sum equal to 0. So let me not put a semicolon so that as many variables are required, that many variables I can declare. Next, let me ask, enter the array size. Printf, enter array size. Then what I will write? Scanf %d %n. So now what I have to do, so in place of n, you can enter 10, 20, 30, 100, any integer, right? Next what I have to do, I have to allocate n amount of memory dynamically. So for that, which function I will use? I will call the Malloc function. So a equal to integer pointer, so that it can convert the void pointer to integer pointer. Then here I will write malloc. Then I have to specify the size. That is nothing but n into size of integer, right? So it will occupy n into, suppose size of integer is 4 bytes, so it will occupy n into 4 bytes dynamically, and it returns the starting address which will be stored inside A. But if the memory is not available, malloc will return what? It will return a null. So after writing this statement, what I have to check, if A equal to null, it means what? Memory is not available contiguously. So what you will do? You will terminate the program. So if A doesn't contain null, it means what? Sir, memory is available, so that you can now proceed with your program. So I will proceed. So if A equal to null, exit 0, I will terminate the program. Otherwise, what I will do? I will ask to initialize the array elements. So printf, enter array elements. So here what you will take? You will take a for loop for I equal to 0, I less than n, I plus plus. Then here what you will do? Scanf %d ampersand a of I. So I have already told you, instead of a of I ampersand a of I, what you can write, you can also write a plus I, right? This is the pointer notation that I have already told you. Next, what you will do, you want to find the sum of array elements. After accepting an element, what you will do sum equal to sum plus a of I. So that a of I will be added to sum, right? Next, what you will do, you have computed the sum, now you can print it. So printf sum equal to percentage d, and here in place of percentage d, you want to print the value of sum. Then return. Okay, before return 0, what I have to do? I have to free the dynamically allocated space. So here I will write free A, right? Next I will terminate the program. So here let me put a semicolon, right? So now you see in dynamic memory allocation, for dynamic memory allocation, I have just added this much of things. Okay, I have used the Malloc function to allocate the memory dynamically. Then I have tested whether the memory is available or not. If a equal to null, it means memory is not available. I will terminate the program. Otherwise, I will go on allocating the memory and I will use that memory as per my requirement. Right? Now I will write the same program by using function. Okay. So here, in order to find sum, I have written a simple one function, that is the main function, and I have allocated the memory dynamically, and then I have find the sum of the array elements. Now what I will do, I will write the same program but by using a function. I will use a user defined function find sum. So every function has how many parts, dear students? Every function has how many parts?
Two.
Three parts.
Three parts.
Two.
What are the three parts?
Function prototype, function call, function definition.
Very good. Function prototype, function call, and function body or function definition, right? So I will write a function, user defined function find sum to do the things. So here you see, so first what I will do, I will include the header files. As include stdio.h, then as include std lib.h. Then I need to start the main function, integer main. Now I have to write the prototype, right? So I have to write the prototype. So now you see, in order to write the prototype, I need to, in prototype there are three things. One is return type, one is function name, and another one is number and type of arguments. So if you want to sum the elements of an integer array, what it will return? It will return an integer. So the return type is integer. What is the array name? Let me take the array name as find sum. Right? Next, how many arguments it will take? Sir, it will take the array, which is nothing but a pointer, integer pointer. Next, what else it will take? It will take the size of the array. That is also an integer. Right? So this is the prototype of find sum function. All of you have understood why I have written the prototype like this. You see, I want to take an integer array. So I want to take the size of the array as input. Now the function name you can take anything. I have taken find sum. Next, if you will find the sum of integer array elements, it is an integer. So its return type is also integer. Is that clear? Yeah. Now let me take the array. So I want to allocate it dynamically. So I have taken a pointer, integer pointer a. Then n, size of the array. Then in order to store the result, let me take r. Next, I have to ask the size of the array. So printf, enter the size. Then what I will write? Scanf percentage d ampersand n. Then what I have to do? I have to allocate the array, n elements of the array dynamically. So what I will write? A equal to integer pointer malloc n into size of integer, right? Next I have to test whether that memory is available or not. So if a equal to null, then I will exit 0. I will terminate the program. Otherwise I will continue. So if memory is available, then what I will do, so here you can put a curly bracket, that is also optional because here it contains a single line of statement. Next I have to initialize the array. So printf enter array elements. So for that I need to take a for loop for I equal to 0, I less than n, I plus plus. Then what I will do, I will initialize the array, that is scanf %d ampersand a of I. Right. Next I can call the find sum function to find the sum. So r equal to, what I will write, I will call the find sum function so that it will find the sum of the array. So find sum. So first I will pass the array, that is a, then I will pass the size of the array, that is n. Then the result will be stored inside R because find sum will be called, it is the function call. This is the call, right? So now the result will be stored inside R. So what I will write, printf sum equal to %d comma R. So in R I have stored the sum that will be displayed instead of %d. Then return 0. So this terminates your program. Now you see I have written the prototype of find sum. I have called the function find sum. Now what I will do, I have to write the body of the find sum, or that is function definition of find sum. So the first line of find sum function or first line of function body is called as function declarator that should match with the function prototype, right? So here the return type will be integer, so I will write int. Function name is find sum, I will write find sum. So here I have to declare a pointer, integer. So here I have passed a, let me take another name, pointer b. Now b will point to the array a. Next integer size, let me write s. Next let me compute the sum. So what I will do, here let me take a variable sum equal to 0 and I. Next what I will do, for I equal to 0, I less than s, I plus plus. So for each element I will write the logic for computing the sum. So what I will do, sum equal to sum plus b of I. Next you see, by this logic the sum will be stored inside sum variable, right? Now I have to return the sum. So what I will do, return sum. So this sum will be returned to where? This sum will be returned to the function call, right? So now let me terminate the program. So here let me terminate the function, right? So now you see the program execution will begin from the main function. Next here you have declared a pointer. So here you have declared a pointer a. Here you have declared a pointer a. N and R. Then printf enter the size. Let's say you have entered 5. Let's say you have entered 5. So n will store 5. Next a equal to integer pointer malloc n into size of integer. So you have allocated 5 integers dynamically. 1, 2, 3, 4, 5. Let's say its starting address is 1000. So 1000 will be stored inside A. So now you see A is pointing to the starting address. Next, if A equal to null, no memory is available, so A is not null, malloc will return the starting address, so we can proceed with the program. Next, printf enter the array elements. So here I have entered the array elements, let's say 5, 7, 9, 10, 20, right? Next, R equal to find sum. So it will call the find sum function where we have passed A and N. So when you will call a function, the control will be transferred to the function body, and the actual parameters a will be copied to b, n will be copied to s. So b is a pointer which contains the value of a, that is 1000. So now you see this array a is pointed by this function, right? Sorry, this array a is pointed by the pointer b. So through b we can access the array elements. So here through b I have accessed the array elements. Then it will return the sum. It will come to here. Then after the sum is computed and printed, I have to free the memory location. So here I have to write free a. So the memory that I have allocated dynamically, that can be freed, right? So all of you have understood how to allocate memory dynamically, how to pass an array to a function. Dear students, all of you have understood how to allocate memory dynamically? Dear students, have you understood?
Yes, sir.
Yes, sir.
Are yes or no? किछि तो कुहो. Okay. So now you see. Now let me write another program, right? Another program to find. Okay, you tell me what we will do. You tell me what we will do. So let me write it in the dev C++ editor. Let me write it in the dev C++ editor. Right. Okay, let me write a program to search an element in the array. So you see here I have written the program that is already there. So here you see I will do it dynamically, right? So for dynamically, so let me first make you understand this program, then I will do it dynamically, right? So here you see, here I have taken a user defined function search. Here I have taken a user defined function search. So here you see, so for searching an element, what is required? You require an array, you require the size of the array, and then you want to know the search element, right? So the prototype is what? Int, return type is integer, means it will say, the search function will say whether the element is present or not. If the element is present, it will return the array index, at which index it is present. Otherwise what it will return? It will return -1, right? So the return type is an integer. That's why I have written a return type as integer. The function name is search. That's why I have written the function name is search. So what I have to pass? I have to pass the array. It means I have to pass the starting address of the array. Starting address of the array means it is a pointer, right? So the first argument is integer pointer. The second argument is what? It is the size of the array. That's why I have written size of the array is also an integer. That's why I have written int. Then the next one is what? The search element. So as I have taken an integer array, the search element is again an integer. So this is the prototype of search function, right? Now here you see I have allocated the array statically. That is a of 10 I have directly allocated. Now instead of directly allocating it, if I want to do it dynamically, so what I will do? So you see, so for that what I have to do, I have to use the Malloc, calloc and realloc functions. So in order to use it, I have to include the header file. So hash include std lib.h. So I have included the header file. So instead of static allocation, if I want to do it dynamically, so what I will do, I have to take a pointer, integer pointer a. Next, in order to ask its size, I have to take a variable n. Next, I is the loop counter that I will use, and s is the search element. Now first what I have to ask, enter the size of the array because I want to allocate it dynamically, right? So printf enter the size of the array, right? So next I will accept the size of the array, scanf %d comma ampersand n. Is that clear? So I have asked the size of the array, then I have accepted it. Next I have to allocate that much amount of memory dynamically. So what I will do, a equal to malloc n into size of integer. But you see, malloc will return a void pointer. But a is a which type of pointer? A is a integer pointer. So I have to convert it into integer pointer. So I have to write it as integer pointer. Next, what I will do, I have to check whether the memory is available or not. So for that, if the memory is not available, malloc function will return what? It will return a null. So that null will be stored where? That null will be stored inside A. So here what I will check, if A equal to null, then what I will do, I will terminate the program. Exit. Right? Otherwise what I will do, if the memory is available, so exit 0 will not be executed and I can do the program. Then I have to initialize the array. So you see, so in order to sort, first what you require, so first you require, so let me go to the pointer option. So what you require, first you have asked what is the size of the array n. Suppose you have entered during runtime 100. So what it will do, it will allocate 100 allocations dynamically, 100 integers dynamically. So 100 integers dynamically means you have allocated 100 integers, 1, 2, 3, 4, 100, 99, right? So this is 0, 1, 2, 3, 99. Now what you have to do? Now you have to initialize the array. Let's say here it contains 5, here it contains -7, here it contains 10. So in order to initialize, I have already told you how to initialize the array. So you see, I will tell you one thing, whatever things I have taught you, if you haven't gone through all those things, you cannot understand. That's why what I am doing, I am recording the videos and I am uploading or sending you the links so that you can refer it. So please refer those videos. If you will not understand those things in future, you will not understand anything. And you see, I am revising the programming in C, and today is the last class. From next class onwards, I will start data structure. So before data structure, these concepts need to be clear. So those who haven't understood, please try to revise it, make a note of that. If you will not make a note, you will understand, then you will again forget, right? So here I have to initialize the array elements. Printf enter the array elements. So here I have to take a for loop because there are n elements. So I equal to 0, I less than n, I plus plus. Next here what I will write, scanf %b, comma, %a of I. So I have initialized the array elements. Next what I have to ask, so you see, I have initialized the array elements. Next I have to ask, what is the source element, right? What is the source element? So you have initialized the array, 100, 25, like this. Next you have to ask the source element. So let the source element is 100. So you have to sort this 100 element in the array linearly, right? So you see, what I will do, I will ask the source element. Printf enter the source element. Then what I will get, I have to initialize it. Scanf %b, comma, %s. So I have initialized the source element. Then what I have to do, sir, now you can call the source function. So in order to store the result, let me write I equal to source. So can anybody tell me what should be the function call of sort? Sorts the prototype देखो So you see I have written the function name as sorts. Then here what I have to pass? Dear students, tell me. Okay, let me ask someone.
Name of the array, pointer size, array of the size.
So very good. Name of the array. What is the name of the array? A.
A.
What is the size of the
Size is
array? M.
n.
What is the source element?
S.
S. Now after this what I have to check? If I equal to -1. It means what? If the source function returns -1, it means the element is not found. So here what I will write? Printf the source element is not else what I will do? Else printf the source element is found at %d location. So %d means I. What source will return? That will be stored in I. So if the element is not found, the source function should return -1. Otherwise, it should return the index where the element is present. Right? Then I have to do what? I have allocated the memory dynamically. I have to free it. So free A. Then what I will do? I will terminate my program. Return 0. Right? So you see rest of the things. Let me erase. So now you see, I have written the function prototype of search function. I have called the function over here, that is the prototype. This is the call. Then I have to write the body of the function. Okay. So the first line of function body is called as function declarator, and body is written outside the function, right? So now here you see the return type is int. I have written int. The function name is search. I have written search. The first argument is a integer pointer. I have taken a pointer. The second argument is the size of the array. I have taken n. The third argument is the source element. I have taken source element. Right? Now I have taken a variable I. Then I am checking whether the element is present or not. So if the element is found, so first I have checked with the first element. When I equal to 0, it will test with b of 0. When I equal to 1, it will test with b of 1. When I equal to 2, it will test with b of 2. Similarly, it will check all the elements with the source element. So if the source element is found, it will terminate, that is break. Okay, so if it will break, then what should be the value of I? I should be less than n. If the value of I equal to n, it means the element is not found. Okay, so if the element is not found, it will return -1. If the element is found, it will return I. I is the what? I is the index of the element that is present. Right? So where it will return? It will return to the function call. So this is the function body. So this is the body of the function. Right? So similarly, I have written the program. So let me execute it. Execute, compile and run. So it is taking a bit of time. Okay, what is the problem?
Sir, it has compiled, sir.
It is compiled. So free A. I have written stdlib.h. Yeah, it should be fine. Array. So now you see, let me save it. I've already said. Let me execute it. Compile and run. What is the problem? Oh, here I have to put a semicolon. So file, save, execute, compile and run. So now you see, first it is asked to enter the size of the array. Let me enter the size of the array is height. Okay. Next enter the array elements 1, 23, 34, 56, 3. Now enter the search element. So suppose I want to search 56. So element is present, 56 is present. So here you see the search element is found at third